Hello everyone, welcome to our YouTube presentation of Active Noise Cancellation project. Our goal is to cancel broadband noises using a single channel feed-forward system which would be utilized through least mean square algorithm along with an adaptive FIR filter.
Hello, I'm going to show you a simulation of our active noise cancellation. We generated a sine wave with a random noise added before entering the system. The random noise is the ambiance noise within the room, and the sine wave is the primary noise. The input signal represents a noise picked up from the error mic. The delay in amplification helped model the acoustic signal traveling within the room. The LMS filter represents an algorithm along with an adaptive FIR filter of 120 filter length or number of taps to cancel out the combined noise signals. The LMS filter has a mu coefficient critical for updating the filter's coefficient. Where a smaller mu coefficient, the system will converge but respond slowly. However, for a large mu coefficient, the system will respond faster and may not converge. As you can see, our simulation results. The top graph is the input plus noise. The middle graph is output. The bottom graph is the error. In the error graph, you can see the signal converging but still having noise in the beginning due to the initial weight starting at 0. Here I'm going to use a larger mu value, which is 0.008. I'm going to simulate the results and show you that it will not converge. Signal attempts to converge but does not. Now let's use a smaller mu value, which is going to be 0.0008. It converges, but it takes some time for it to converge.
Our program was written in C language using Code Composer Studio. We decided to use a ping-pong buffering system for the transfer of data inside the DSP. The ping-pong buffering is a technique where two buffers ping and pong are used for the transfer of data. The DMA is configured to use the ping buffer first until it's full, and then the DMA is reconfigured to use the pong buffer. While using the pong buffer, the ping buffer can be processed without fear of being overrated. The program has four main functions. The first one takes care of sorting the input data that is coming from both channels. The second one initializes the DSK codec and the DMA controller. The third one is where our LMS is being implemented, and the last one manages the data transfer through the system.
Here is how our ANC system works. First, we decided to emit a 1 kHz sinusoid wave tone through these speakers, and the reason we did so is simply for demonstration. Here we have our reference microphone, where the noise signal will be picked by this reference microphone and sent to a preamplifier and then to the DSP board. We chose this preamplifier mainly for two reasons. First, our DSP board takes only one input, and by using this preamplifier, we were able to transfer the two microphone inputs into one stereo output, which allowed us to separate the signal into two channels. And the second reason is to be able to control the amplification of the signal and also control the sensitivity of the two microphones. This leads us to our final stage, where we have our error microphone and the cancelling speakers. The error microphone will pick up the desired signal for cancellation and send it to the DSP board, where a set of coefficients and calculation will be made. And finally, the DSP board will send the cancelling signal through these speakers for cancellation.